Hello student, welcome to my channel Learn Physics. Today I will be discussing the solution of 24th January JEE main paper. It is the first of papers 9 am to 12 pm. This solution will be extremely helpful for you for your next entrance examination such as NEET, main and advanced. So let's start. Now question number 1. If two charges Q1 and Q2 are separated with a distance d and placed in a medium of dielectric constant K, what will be the equivalent distance between the charges in air for the same electrostatic force? So look at this. The electrostatic force in a medium is equal to electrostatic force in air. Electrostatic force in the medium is equal to electrostatic force in air. Now here this is the Q1 Q2 divided by 4 pi epsilon naught K d square. Okay. Now this is the Q1 Q2 divided by 4 pi epsilon naught. This is the d1 square. So look at this. This cancel out. This cancel out. Therefore, d1 equals to d into root under k. Okay. Now look at this. Option 4 is correct. Now question number 2. From the photoelectric effect experiment, following observations are made. Identified of these are correct. The stopping potential depends only on the work function. No. Now, if Vs be the stopping potential, then EVS equals to H nu minus W. So, stopping potential not only depends on work function, it depends on nature of radiation. That is the frequency of radiation. Now, option B, the saturation current increases as intensity of incident light increases. Okay, photoelectric current I proportional to intensity of radiation. So, option B is correct. The maximum kinetic energy of photoelectron depends on the intensity of incident radiation. No. This is not correct. You know, the maximum kinetic energy of photoelectron depends on nature of metal surface and nature of radiation incident on it. Now D, the photoelectric effect can be explained using wave theory. No. So only B option is correct. Okay, understood? Next. Now look at this question number 3. A conducting circular loop of radius r by pi can be placed perpendicular to a magnetic field of 0.5 Tesla. The magnetic field is decreased from 0. The magnetic field is decreased to 0 in 0.5 second in a steady rate. The induced EMF. Now look at this. The data given, area A equal to, this is the pi into r square. R is the 10 by root pi. So this is the 10 by root pi. This is the whole square. So look at this, 100 centimeter square. So this is the 0.01 meter square. Here dB by dt, that is rate of change of magnetic field. Look at this, 0. This is the 0 minus 0.5 divided by 0.5. So look at this. This is the minus 1 Tesla per second. Therefore, induced EMF E equal to, this is the A minus A dB by dt. Okay. Look at this. A is the 0.01 and this negative sign and this negative sign cancel out and this is the 1. So this is the magnitude of induced EMF. So this is the 0.01 volt. Okay. Now 0.01 volt. So this equals to 10 millivolt. Okay. Look at this. Option A is correct. Okay. Now look at this. Statement type question, statement 1 and statement 2. Look at this. An elevator can go up or down with uniform speed when its weight is balanced by the tension of its cable. Yes, the tension of the cable when lift move up or move down with constant velocity. This is the T equal to mg. Therefore, statement 1 is correct. Understood? Now, statement 2. The force exerted by the floor of an elevator on the foot of a person standing on it is more than his or her weight when elevator goes down with increasing speed. Look at this, increasing speed means acceleration. So here tension T equal to, so here reaction R equal to m into G minus E. Look at this, this is the less than mg. So this is the incorrect statement. So look at this, statement 1 is true, but statement 2 is false. 2 is false. Therefore, look at this, statement 1 is true and statement 2 is false. So option 4 is correct. Okay. Now look at this, question number 5. Two long straight wires P and Q carrying a current 10 ampere each were kept parallel to each other at a distance 5 centimeter. The magnitude of magnetic force experienced by 10 centimeter length of wire P is F1. Now look at this. This is the wire P and this is the wire Q. Okay. Now look at this. Each current 10 ampere. Okay, distance of separation, this is the 5 centimeter. Therefore, the magnitude of force, this is the F1, this equals to mu naught by 4 pi. This is the 2 I1 I2 divided by R into N. So look at this. In the second case, the distance between them is half. If this distance half, so force becomes 2 times. 2 times. Now current on each conductor is double. So I1 double and I2 also double. So 2 to 4 times. So this is the 2 into 4. So magnitude of force is 8 times. So this is the 8F1. Now look at this. Option A is correct. Okay. Question number 6. Statement 1. If the Brewster's if the Brewster angle for the light propagating from air to glass is theta b. Then Brewster angle for the light propagating from glass to air is, look at this, Brewster angle tan theta b. This equal to, this is the air mu glass. Now mu air glass. Now, glass mu air, this equal to 1 by tan theta b. Okay, no problem. Therefore, this is the cot theta b. Okay. Now, cot theta b can be represented as tan of 90 degree minus theta b. Okay. So, this statement is correct. Okay, no problem. Now two. The Brewster angle for the light propagating from glass to air is tan inverse mu g, where mu g is the refractive index of glass. This is the false statement. Okay, so statement 1 is correct and statement 2 is false. Now look at this. Both statement 1 and 2 are false. No, 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 no. The statement 1 is false. No, 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 no. Both the statement true. No, 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 no. The statement 1 is true and 2 is false. So option 4 is correct. Understood? Now look at this question number 7. The maximum vertical height to which a man can throw a ball is 136 meter. The maximum horizontal up to which he can throw the same ball is, which can up to which he can throw the same ball is. Look at this, the maximum height, this equal to u square by 2g, and maximum horizontal range r equals to, this is the u square by g. So look at this, these are 2 into u square by 2g. Okay, So this is the 2 into h. So this is the 2 into 136 meter. So this is the 272. Look at this, option 1 is correct. Understood? Now question number 8. A circular loop of radius r is carrying current 1 ampere. If the ratio of magnetic field at the center of the circular loop and at a distance r from the center of the loop on its axis is. Now look at this question number 8. A circular loop of radius r is carrying current 1 ampere. The ratio of magnetic field at the center of the circular loop at a distance r from the center of the loop on its axis. So look at this, you have to calculate magnetic field at the center and magnetic field on the axis. Now look at this. We have to calculate magnetic field on the axis. So magnetic field on the axis, this is the mu naught by 4 pi. This is the 2m by dq. Where m is equal to, this is the ai. A is the area of the coil and I is the current through it. So this is the pi r square. Okay. And d is the, look at this, distance of the point on the axis from the periphery of the conductor. So this is the r square plus r square. So this is the root 1. Now look at this. This is the mu naught by 4 pi. This is the 2 into, this is the pi r square I divided by, look at the d cube. So this is the 2 root 2 r cube. Okay. So look at this pi cancel out, this 2, this 4 cancel out, 2 cancel out. So look at this is the mu naught I divided by 2r into 1 by 2 root 2. Now this is the magnetic field at the center. So this is the magnetic field at the center and this is into 2 root. Okay. Therefore magnetic field at center divided by magnetic field on the axis, this equals to 2 root 2. Okay. So look at this, option 2 is correct. Understood? Next. This question number 9. A traveling wave is described by the equation y equals to, this is the 0.05 sine 8x minus 40 meter. The velocity of the wave is. Look at this, all quantities are in SI unit. Now you know the velocity of the wave is the coefficient of t, that is the 4, divided by coefficient of x. So velocity of the wave is 0.5 meter per second. Look at this, option 4 is correct. Okay, next. Now again there is statement. Now again is statement type question. Now statement 1. The temperature of gas is minus 73 Celsius. When the gas is heated to 527 degrees Celsius, the root mean square velocity speed of the molecule is doubled. Now look at this. Now T1 is the minus 273 plus, now T1 is the minus 73 plus 273. So this is the 200 Kelvin. Okay. Now T2 is the, look at this, T2 is the, this is the 527 plus 273. So look at this is the 800. So ratio of T2 by T1, this is the 800 divided by 200. So look at this is the 4. Therefore C2 square by C1 square, this equal to 4. This equal to 4. Therefore C2 by C1, this is the 2. Therefore RMS speed becomes double. Okay. Now so look at this, statement 1 is correct. Now statement 2. If the product of pressure and volume of an ideal gas will be equal to the translational kinetic energy of the molecule. Look at this. The translational kinetic energy, this is the half mc square. This equals to 3 by 2 kT. Okay. Now look at this. So total energy, look at this. Now total energy E equal to, this is the half mn c square. This equal to 3 by 2 RT. Now RT equal to PV, so 3 by 2 PV. So look at this, this is not correct. So statement 1 is correct, but statement 2 is false. Now look at this, statement 1 is true, but statement 2 is false. Okay, understood? Next, a network of resistors is connected to a battery of 24 volt with an internal resistance 3 ohm. The current through the resistor R4 and R5 be I4, and the current through the resistor R4 and R5 is I4 and I5 respectively. Then values of I4 and I5 are. Now look at this. This is the resistor R1. This is the 2 ohm. This is the resistor R2. This also 2 ohm. Now equivalent resistance of these two, this is the 1 ohm. This is the R3. This is the 2 ohm. So 1 ohm plus 2 ohm. So this is the 3 ohm. Now this is the R4. R4 is the 20 ohm and R5 is the 5 ohm. Now equivalent resistance of 20 and 5, this is the 20 into 5 divided by 20 plus 5. So look at this, this is the 4 ohm. So 4 ohm and 3 ohm, so this is the 7 ohm. 7 ohm plus 2 ohm, this is the 9 ohm. 9 ohm plus 3 ohm, this is the 12 ohm. So current, look at this, the current I is equal to, this is the 24 by 12. So this is the 2 ampere. Okay. Now voltage across this equal to, this is the 2 into resistance 4. So this is the 8 volt. Now current through R4. So R4 equals to, this is the 8 by 20. So this is the 2 by 5 ampere. Okay. And I5 is the, this is the 8 volt divided by 5 ohm. So this is the 8 by 5 ampere. Okay. Understood? Look at this. Options are three. I4 is the 2 by 5 and I5 is the 8 by 5. So option 3 is correct. Okay. Next. Now look at this question number 12. A 100-meter long wire having a cross-sectional area 6.25 into 10 to the power minus 4 meter square. The Young modulus is 10 to the power 10 Newton per meter square is subjected to a load of 250 Newton. Then elongation of the wire will be. Look at this. The elongation of the wire small l equals to, this is the force into length divided by A into Young modulus. Okay. Now look at this. Tension is the 250 Newton. Length of the wire, this is the 100 meter. Now area of cross section, this is the 6.25 into 10 to the power minus 4. And Young modulus is the 10 to the power 10. Now 10 to the power minus 4 and 10 to the power 10. So this is 10 to the power 6. Therefore, look at this. This is the 25 into, this is the 10 to the power 3 divided by, this is the 6.25 into 10 to the power, this is the 6. Now look at this and this is the 4. Therefore 4 into 10 to the power minus 3 meter is the elongation. That is, look at this, option C is correct. Okay. Next. Now question number 3. As per given figure, a weightless pulley P is attached on a double inclined frictionless surface. The tension in the string, look at this, we have to calculate tension. Now, first of all, we have to calculate acceleration. Now, acceleration is the net force by total mass. What is the total mass? Look at this, total mass is the 4 plus 1, this is the 5. Now net force, look at this, net force is the 40 into sine, this is the 60 degree. And here this is the 1 into 10 into sine 30 degree. Okay, no problem. Therefore, look at this is the 10. Now look at this is the 40 into root 3 by 2 minus 10 into half divided by 5. Okay, so look at this. This is the 20 root 3 minus 5. This divided by 5. So look at this. This is the 4 root 3 minus 1 is the acceleration. Now tension. Look at this. This 1 kg mass moves up. If T be the tension, so look at this T minus, this is the 1 into 10 into sine 30 degree. Net force acting in the upward direction. This equal to mass into acceleration. What is mass? Mass 1 and acceleration is the 4 root 3 minus 1. Now the value of this is the 5 Newton. Therefore, T equals to, this is the 4 root 3 minus 1 plus 5. So look at this, 4 into root 3 plus 1 is the tension. Look at this, option A is correct. Understood? Now question number 14. 1 gram of liquid is converted to vapor at 3 into 10 to the power 5 Pascal pressure. If 10% of heat supplied is used to increasing the volume by 1600 cc during this phase change, then the increase in internal energy. So look at this, 10% of heat supplied is used to increasing its volume. So rest of 90% is used to increasing the internal energy. So increase of internal energy is 9 times the work done. Okay, so look at this is the 9 into delta W. What is the delta W? This is the 9 into P delta V. Look at this, delta V, this is the 1600 cc. P is the 3 into 10 to the power 5 Pascal. So look at this is the 9 into 3 into 10 to the power 5, and delta V, this is the 1600 cc. This should be converted into meter cube. So this is the 10 to the power minus 6 joule. Now this and this is the 1 by 10. So look at this is the 27 into 160 joule. Therefore, this is the 4320 joule. Okay. Now look at this question number 15. A modulating signal is square wave as shown in the figure. Look at this. This is the modulating wave. Okay. Now this is the modulated wave. Look at this. This is the 1. This is the minus 1. This is the 1. This is the minus 1. This is the 1. Okay. If the carrier wave is given by 2 sine 8 pi t volt, the modulation index is, look at this, the modulation index mu equals to, this is the amplitude of the signal, this is the 1, and the divided by amplitude of the carrier wave 2. So option 2 is correct. Now look at this question number 16. There is a matching type question, list 1 and list 2. Now Planck's constant. The dimension of Planck's constant ml square t minus 1. So look at this. This is the A. Stopping potential. That is the potential difference. Work done by charge. Look at this. This is the B. Okay. Work function. That is the energy. Look at this. This is the C. And momentum ml t minus 1. So this is the D. Okay. Now look at this A3, B4, C1 and D2. So option 4 is correct. Okay, understood. Next. Question number 16. There is a assertion reasoning type question. Look at this. The photodiode A is preferably operated in reverse bias condition for light intensity measurement. The current in the forward bias is more than the current in the reverse bias for a PN junction diode. Okay, this is correct and this also correct, but these are not correct explanation of A. So look at this, option C is correct. Okay, question number 18. Consider the following radioactive decay process. Look at this A84 to 218 alpha decay. So look at this. This becomes 214. This is the 82. Now beta decay. So no change of mass 214 and this is the 83. Okay. Now gamma no change. So 214 divided by 214 and 83. Now alpha decay, so 210, this is the 81. Now beta decay, look at this, same. So 210 mass number same, but atomic number increased by 1. Gamma decay, no change. So look at this, option A is correct. Okay. Now question number 19. The weight of a body at the surface of Earth is 80 Newton. The weight of the body at an altitude of 3200 kilometer. Now radius of the earth is 6400 kilometer. So 32 kilometer. So 3200 kilometer is half of radius. Okay. Now look at this here. Mg dash by mg. This equal to, this is the r divided by r plus h whole square. Okay. No problem. So look at this. This is the r divided by, this is 3200 kilometers. So this is the r by 2. This is whole square. So look at this. This is the 4 by 9. Now mg is equal to 18. Look at this. This is the 18 Newton. Therefore mg dash, this equals to 18 into 4 by 9. So this is the 8 Newton. Okay. Look at this here. K vector is the propagation vector. E is the electric field vector. So look at this K vector cross E vector. This equal to rate of change of magnetic field with respect to time. Now 1 by time is equal to omega. So look at this. This is the A vector cross E vector. This equal to omega into this is the B. Okay. So look at this option. Look at this option A is correct. Okay. Now question number 21. As shown in the figure, the combination of a thin plano concave lens. Look at this. This is the thin plano concave lens. And a thin plano convex lens. Look at this. This is the thin plano convex lens. Okay. Is, is used to form image of an object placed at infinity. Okay. This is the parallel rays incident on it. Okay. The radius of curvature of both the lenses is 30 centimeter. Okay. And Ri, look at this here. R is equal to, this is the 30 centimeter. Mu is equal to, this is the 1.75. So first of all, we have to calculate focal length of it. Now, both the lenses are placed at a distance 40 centimeter from each other. Look at this. This is the 40 centimeter. No problem. Due to due to this combination, the image of an object formed at a distance x from the concave lens. Look at this. The final image is formed at a distance x from the concave lens. We have to calculate this distance x. So first of all, focal length of each lens will be equal, but focal length of convex lens is positive. So look at this 1 by f. This is the 1.75 minus 1. This is the mu minus 1 into 1 by r1 plus 1 by r2. So look at this. This is the 1 by 30. So look at this. This is the 0.75 divided by 30. So look at this. This is the 140. So focal length of this lens, this is the f equals to 40 centimeter, and focal length of this lens, this is the f equal to minus 40 centimeter. When parallel rays incident on this lens, the ray appear to converge at this point at a distance of 40 centimeter from this lens. Now this image acts as the object for the convex lens. So distance of object from the convex lens, look at this. This is the 40 centimeter, and this also 40 centimeter, 80 centimeter. So object distance for convex lens, this is the minus 80 centimeter. Focal length is the 40 centimeter. So look at this, object is at a distance of 2f from the lens. So image is also at 2f. Therefore, the final image is formed at a distance of 80 centimeter from the convex lens. So, a distance of this image from this lens, this is the 80 plus 40. So, this is the 120. Therefore, the option is 120. Okay. So, this is the 120 centimeter from the concave lens. Okay. Now, look at this question number 22. A hollow cylindrical conductor has length 3.14 meter, while the inner and outer diameter is 4 millimeter and 5 millimeter respectively. The resistance of the conductor is N into 10 to the power minus 3 ohm. Okay. If the resistivity is the 2.4 in 10 to the power minus 8 ohm meter, then the value of N. Look at this. This is the hollow conductor. Okay. This is the inner radius and this is the outer radius. Length is, look at this, length is 3.14 meter. Okay. So resistance of this hollow conductor is equal to, look at this is the R equal to, this is the 4 rho L divided by pi into, this is the d2 square minus d1 square. Okay. Now look at this, here 4 into rho is the 2.4 into 10 to the power minus 8, L is the 3.14 divide by, look at this is the pi into, look at this, d2 square, that is 5 square minus 4 square. So this is the 3 square. So 3 square means 3 by millimeter should be converted into meter whole square. Okay, no problem. This and this cancel out. Therefore, look at this is the pi. Now this is the 4 into 2.4 into 10 to the power minus 2 divided by 9. Okay. Now look at this and this cancel out. So this is the, look at this is the minus 8 by 3. So look at this is the 3.2 by 3 into 10 to the power minus 2. So look at this is the 32 by 3 into 10 to the power minus 3. So the answer is, this is the 32 by 3. So n is, this is the 32 by 3. Okay. Now question number 20. Assume the proton and neutron have equal masses. Mass of mass of nucleon is 1.6 in 10 to the power minus 27 kg, and radius of the nucleon is 1.5 in 10 to the power minus 15. This is the 1.5 10 to the 15. The approximate ratio of the nuclear density and water density is, look at this. Here radius R is equal to, this is the 1.5 into 10 to the power minus 15 a to the power 1. Okay. So density of the nucleus rho equals to, this is the mass. Suppose mass number be A. A into, this is the 1.6 into 10 to the power minus 27 whole divided by, this is the 4/3 pi, and this is the R cube. So R cube means 1.5 into 10 to the power, this is the minus 15 whole cube, this into A. Now A cancel out. Therefore, this is the 1.6 into 3 divided by, this is the 4 pi into, this is the 1.5 cube into, this is the 45 minus 45 minus 45 17. So this is the 10 to the power minus 8. So this is the 10 to the power 18. Now look at this is the 16 into 3 into 10 to the power 17. This divided by, this is the 12 pi. Now look at, this is the 4 pi. So this is the 12 point. So this is the 12.56. And this is the 1.5 into, this is the 2.25. Okay. Now look at this 1.5 and 3. So this is the 2. Now this and this almost 1, and this almost, this is the 12. 12, this is the 4 by 3. This is the 4 by 3. Okay. So ratio between, look at this. So this is almost 1. Therefore, ratio between nuclear density 10 to the power 17 by 10 to the power, this is the 3. So look at this. This is the 10 to the power 14. Therefore, this is the 10 to the power 13. So this is the 10 into 10 to the power 13. Okay. So here 10 is the correct option. Okay. Many thanks for watching this video. This video will be extremely helpful for your upcoming NEET and main examination. Please like, share and comment on the video. Okay.